So I wanted to include this report that just came out from the World Health Organization reporting the issues with air quality around the world. They do it by region, very nice detailed report. I'm going to show the global map and then zoom into South Asia and India, but obviously you can read this report for your region if you're interested. So let's just start with the introduction of particulate size matters. Obviously a obvious line one could use here. This is comparing sizes. Small particles pose the greatest risk to human beings, and PM 2.5 is always the most dangerous one that you breathe in. It seems to get into your digestive system, bloodstream, brain. It enhances, of course, chronic obstructive pulmonary diseases, asthma, diabetes, hypertension, and all sorts of other things. While the nose can filter most coarse particles, fine and ultrafine particles are inhaled deeper into the lungs, where they can be deposited or even pass into the bloodstream. This has become quite dangerous. Measurements indicate microns or micrometers. So we are going here from soot, which is the smallest one in this map, 0.01 to 0.3 micrometers, smoke 0.01 to 10. Influenza A virus is even larger than soot here. Coronavirus is larger. Pet dander, you know, the things that dogs and cats shed. Dust mite allergies, T4 bacteriophage, bacteria themselves, dust, respiratory droplets, red blood cells. You can see the size is much larger than some of the pollution we are producing. Mold spores, which is a dangerous thing that often happens after floods in tropical countries or even high latitude countries. Pollen, white blood cells, sand, salt grain, and fine beach sand. And here is, for comparison, human hair size, which goes from 50 to 100 micrometers visible to naked eyes. Of course, most of the pollution is often not visible, and you will have a lot of people in Mumbai thinking air is very pure because they keep thinking about Delhi and how bad it is. The approach used here, 2021 World Air Quality Report Visualization Framework, which has a very nice interactive graphics report online that you should visit. So they're looking at annual PM 2.5 breakpoints based on 2021 WHO guidelines and interim targets. We should say that sometimes countries set a higher threshold for air quality acceptable limits compared to WHO standards. WHO may be setting 10 to 12 micrograms per meter cube as the threshold above which air quality is bad, but some countries may set it to 20 based on their own data and so on. So depending on who meets PM 2.5 guidelines from the World Health Organization, you're in blue color in the map. We will look at for PM 2.5, which is 0 to 5 milligram per meter cube. Color code is blue, and this is the WHO standard. And the various color codes here exceeding 1 to 2 times, 2 to 3 times, 3 to 5, 5 to 7, 7 to 10, and over 10 times the WHO standards in this kind of brownish color. So just try to keep that in mind. So here we have air quality guideline, interim target 4, interim target 3, interim target 2, 1, exceeding target levels, and exceeds target levels here as well, going from color codes of blue, green, yellow, orange, red, purple to maroon. This is the color maroon. Okay, greater than 50 milligrams per meter cube, and we'll see that some of the numbers for some of the regions are much higher than that. Okay, so remembering that color code, this is really bad here, exceeding targets, also exceeding targets, and within limits over here. And you'll see that there is nobody here who is in the blue color. Most are green and above, and there are some regions where maroon begins to show up, here in Central Africa, India, exceeding targets. Our neighbors, Pakistan, Nepal, Bangladesh. China is a little bit lower. And one thing we should remember for a country like India or this monsoon domain is that just looking at air quality inside is not always enough, because the monsoon circulation, which goes from southwest to northeast during the boreal summer months, comes from the northeast to southwest during the boreal winter months. So obviously pollution gets advected, and of course there is evidence that pollution can go all the way across from China over to the US, for example. And there are many places where there is no data, there's no monitoring network, so it doesn't mean that the air is clear, it's just that there is no data coming in, like on Greenland, for example. Okay, but now there's plenty of evidence that soot is going all the way into Antarctica and Greenland and these parts of Norway as well, and so on. So it's unfortunate that such large parts of the world are not covered by monitoring centers. The report does provide a map of where the air quality is being monitored. Fortunately, China and India are well covered, two of the most polluted countries. So zooming into Central and South Asia, we are covering Afghanistan, Bangladesh, India, Iran, Kazakhstan, Kyrgyzstan, Nepal, Pakistan, Sri Lanka, Tajikistan, and Turkmenistan. And you can see the various levels of exceedances of WHO standards happening here, and Mumbai is here clearly exceeding the targets. Some of the worst exceedances are over here, especially Delhi. So country and region by ranking, Bangladesh, unfortunately a poor country, has some of the worst air quality PM2.5 loading of 76.9 micrograms per meter cube, way past the target set by any air quality standards. Pakistan is pretty bad. Tajikistan, India stands here at 4th, and China is not even in the top 12 list here. That's because we are only looking at South Asia and Central Asia and not China. You can go to China map for looking at those things, which I didn't include in here. So Sri Lanka is the lowest on here, but even that has the orange color, which obviously is let's see, 3 to 5 times higher, I think, than the standards. Most polluted regional cities go to Bhiwadi, India, Ghaziabad, Delhi is here. Look at the levels here, horrendously high levels. And down here to Lucknow, Pakistan is in here. 2 cities, 3 cities, Bangladesh, Dhaka should have been here. But anyway, least polluted regional cities are in Kazakhstan, Sri Lanka, Iran, and so on and so forth. Okay, so I won't read all of those, but you can see that some of them have very good air qualities below 5 micrograms per meter cube for PM2.5. India, zooming in from South Asia and Central Asia into India, you can again see more clearly Delhi is a nightmare. Mumbai, which people think is clean, is not good at all. Pune, Bengaluru is a little bit better than this, but still not very good. Chennai down here also pretty bad. If you look at the changes over the last few years in terms of PM2.5 annual average micrograms per meter cube over the last 5 years, scale going from 20, which is already way above the WHO standard of 5 micrograms per meter cube for suggested standards, and India typically considers, I think, 20 micrograms per meter cube is to be acceptable. Alright, you have to check the numbers, but that's not good. Okay, so here is Delhi, Kolkata, Mumbai, Chennai, Bengaluru, and Hyderabad. Delhi is above everybody else, much higher. Kanpur is not included here, which should be somewhere here, which is also pretty bad because of manufacturing industries and so on. This is Kolkata, which is quite bad. Mumbai, the greenish color is here, which is worse than Hyderabad, and Bengaluru. Bengaluru here is like the cleanest, and yet it has gone up here in 2021 than Chennai. is a blue color Chennai? Yes. Okay, so just keep those things in mind. But if you look at 2020 to 2021, Delhi, which because of COVID lockdowns got a little bit cleaner, is bounced back to 96.4. There's a very strong seasonality because of winter inversions, crop burning, vehicular miles traveled, and so on and so forth. Kolkata was down in 2020 but jumped back up to 59 micrograms per meter cube. Mumbai was down at 41, went up a little bit. Hyderabad also went up a little bit. So all of them have consistently gone up, except Chennai here seems to show slightly higher number in 2020, but basically not much difference from 2021. Similarly, Bengaluru, which are kind of the lowest on this list. Fortunately, there is a lot of monitoring happening, a lot of advisories being issued. India has invested a lot in issuing air quality advisories and heat waves and so on. So annual hours spent at different PM 2.5 pollution levels is not good news at all. So 2019 was at 63% for Delhi here, and this is basically a percentage of people spending time in PM 2.5 pollution levels, which went down in 2020 because of COVID, but it's inching up again by 2021 and probably is going to keep going up as the pandemic disappears. So unless quick actions are taken to do the green recovery funds, public transportation, restrictions on driving, Sunday no cars in the city, and so on, pretty much anything they have tried in Delhi has not worked so far in terms of alternate license plate permissions to come in during the week and so on and so forth. So it remains a disaster, and hopefully it'll get better. WHO report also reminds us what governments can do. So decreasing air pollution emissions, individuals have to do that, and individuals also have to protect themselves against pollution while jogging outside, traveling outside, public transportation, walking outside, bicycling outside, and so on. But decreasing air pollution emissions would require passing legislation to incentivize the use of clean air vehicles for personal and industrial use, invest in renewable energy sources, provide financial incentives such as trade-in programs to limit the use of ICEs or internal combustion engines, provide subsidies to encourage the use of battery and human power transportation methods. There is issues here, of course. You can increase the number of EVs, but unless the energy systems also transition to clean energy, you are going to be charging batteries with dirty fuel, so grid emissions are going to go up as well. Expand public transportation and power with clean and renewable energy sources. That's the point. Build additional infrastructure to encourage pedestrian and bicycle traffic. Hard to retrofit many of the cities in India, but still can be thought of for the decadal timescale planning. Strengthen and enforce emission limits for vehicles and industry, which can be done, should be done. Adopt new air quality standards based on the 2021 World Health Organization air quality guidelines. Implement forest management strategies to limit wildfires. This is very critical. Biomass burning is still very high in India as a fuel source, which has to be dealt with as well. Ban agricultural and biomass burning, which is a large problem in northwest India. Incentivizing it and changing behavior is critical. Develop innovative civic strategies for improving air quality. So we are all in this together, so obviously we'll have to work together to improve air quality, because nobody is breathing clean air anymore, and this is a tragedy which must be averted before it's too late. Especially for the young and the old, air quality can be a disaster. If they want to stay healthy and walk around, but they have to breathe dirty air, then it's going to be not a very good situation. So this is a new finding in terms of the report that came out of WHO, so I've included it here, but you can also consider it under climate impacts and so on. Okay.